Alright, good morning. Yeah, sorry the desks are kind of weird. Find a desk. There's no seating chart for this arrangement. The other classes, oh, 8 and 9. Okay, alright guys, so, good morning. Remind me to hand back your exit cards from the other day. I had them out to hand back the third period and I forgot. Oh well. So I do want to hand them back, but it'll distract you right now if I do it. Couple announcements. Long weekend, you have Monday off. After a long hot week here. And we've got no
Morning,
parallel
BCC
today.
and party. This announcement. At this time, all students should be in class. Hallways should be clear. If you're not in class, you will be marked target unexcused. All PMDs, including headphones, earbuds, and smartwatches should be turned off and out of sight. Teachers, please remember that students should not be leaving the first 10 and last 10 minutes of class. If they leave for any reason, bathroom, drink, counselor, main office, students must have a paper pass. Students without a pass will be escorted back to class to get a pass. Right, just another reminder, we are on a regular schedule today.
Guys,
Thank
all
you.
of you get your packet out. So if you don't have your packet, get your paper.
I just heard.
Okay, Emma and Maud, not a good combination. Emma, do you have your packet? Oh, yeah. All right, so Wednesday you're gonna have an entrance cards. Doesn't say it on here, but it says it on the next page. An entrance card that is really similar to what's on the Delta map. So highly recommend that you do the Delta map because it will prepare you for the entrance card. Out there, that's the nearest empty desk. Weird seating because calculus after this has a test. And I don't like moving the desk this way and that way. Yes, ma'am.
What is the Delta map?
When is the Delta math due? Wednesday morning at 7 a.m.
Okay, sorry.
As it says
Yeah.
there.
I got it.
Okay. Today we're gonna do graphing piecewise functions, and that was a thing you did in Algebra 2. But now we're also gonna look at those piecewise functions and then do the limits with respect to the left and right of those and identify the kinds of discontinuities that happen there. So, in getting you to warm up to this, this is the top of page 8 in your packet. Yes? So, first thing you guys need to do on that is decide where to draw your axes. Usually dead center works well, but let's make sure. What do I need to check to see where a good place to put axes are? What does this mean? Okay, so John Gideon says, Gene Gideon, for all x values less than 5, so to the left. So I'm going to draw a line for the y-axis this way, because that has at least 5 spaces this direction. Now, where should I put the y-axis? Yeah, like should I put it up high, down low, or in the middle, and why?
high kills.
This high, like at the very, very top? No?
Like, how
Down 4 blocks, 5 blocks, 8 blocks, 1 block?
four blocks down.
Why 4? Why exactly 4?
Clearly says possible.
Because that is the y-intercept. So you know what, I'm gonna do it 5, just for grins. Okay. Oh. Now that I'm thinking about it, I should move that. But I won't, I'll leave it where it is, because that's what we picked. So he says the y-intercept is 4. When x is 0, plugging in 0 for x, that's a 4. All right? And I put it in as a solid dot. Hosea, why did I put it in as a solid dot? I want to draw the line for every value of x less than 5. Is 0 less than 5?
Yeah.
So then I'm going to color it in, right? Danny, how do I graph the line? Jean Gideon said, right, to the left. So this isn't the left of 5, this is the left of 0, which is also, right? So from here, how do I graph it?
Go to the left.
So it's a negative slope, but it's going the
Oh, yeah.
other way. So I
Oh,
would
yes,
go
so go up 2 and then
back 5.
back 5.
Okay, so it's like over there. If I went forward, I would go down to over 5. Open circle or closed circle, Maud? On this, at 5 itself, do I color it in or not?
No.
Why do you say it with a question mark? Like, no, because, what's your evidence?
Does it already have the colors in
Wrong evidence.
Because there is no equal sign.
Thank you. Open mouth on that one, there's no equal sign, no solid line, no solid dot, it's an open. Okay. Alistair, can you see from there? No? Okay. Alex, how about you? Doing okay?
Yeah.
And you and Alex or Alexander? I, okay. So piecewise function, there it is. That's just the piece that we want, no more, no less. Lydette, you okay with that, or do you have a question?
No. No, I get it.
Khalil, good? All right. Because we did some of these graphs yesterday. This one, I'm gonna make my axes there. Why am I putting the y-axis so high up? Alistair?
Because the y value is at -11.
Well, that whole, that -11 shifts the entire graph down 11, yes. All right, can you guys try graphing that on your own? Just the piece that is greater than or equal to -3. starting there and moving
Do we have
forward,
to-
going towards the bigger X's. So it's gonna be, just half of its face. Maybe you draw an axis on it.
Oh, I know.
Okay, so, this is a good graph, except we need to cut some of it off. Alright, so what I'm seeing people do, which we graphed it yesterday. The vertex of this parabola is -3, -11. Like, the form that it's in, that shows well. It says greater than or equal to. Brianna, solid dot or open?
Okay.
Open? Why?
Because I'm not actually sure, but I know that like the thing is like -2.
Okay. Solid line under there for the equals, solid dot. That was last period. It's fourth, alright. His name isn't really Bob, I call him Silent Bob. What? Okay, solid line, solid dot. Abraham, where are the bigger X values? Towards the door or towards the wall behind you?
Either just negative or positive.
Okay, okay. What values give me this branch that I'm looking for? I want X values greater than or equal to -3. That's not an either, that is distinctly, it's this way or it's that
Oh,
way.
so it's an opposite.
I'm not answering the question I'm asking.
That's it, right?
What X's are bigger than -3? Towards 0? Yes, that way. Yeah,
No.
okay. So, then people were asking like, how do you graph it from there? Well, you know, if you don't know, pick a number. Like an easy number to plug in, -2, that's that direction. -2 plus 3 is 1, 1 squared is 1, 1 minus 11 is -10. And then putting in 0, 0 plus 3 is 3, 3 squared is 9, 9 minus 11 is -2. And it's just half of the happy face. A lot of you, I saw the whole parabola. I don't want the whole parabola, I only want the part that is equal, x equal to -3 and bigger. Fernando, how do I do the last one? Federico? Fernando? Fernando, yeah.
Yeah,
How do I do the last one?
like the entire process.
Yeah.
Okay, so first, x values that are greater than -2. Right. So then you're gonna find like the,
So can I put my axis here and maybe there?
yeah, those, there's also the one that's like
The
negative.
y-intercept is pretty low.
So,
I might have missed on some things, but you said it starts, the graph starts at -2 and it gets bigger.
mhm.
So Abraham, are you okay with that? That,
I go to the bathroom now.
you can wait a second, so how do I finish?
So then you're gonna plug in like -2, right? To get -6 minus 8.
-14, so off my grid, so I didn't choose a good one.
Yeah.
Okay, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so down here, is it gonna be a
Open circle.
open circle? Abraham, why is it an open circle?
Because it's not equal sign.
Because there's no equal sign. Okay, what's the y-intercept? So when x is 0, negative 8. Okay? Is that why? Yep.
Why are we plugging negatives too? Couldn't you just like down the slope and just be like 3 of them?
Okay, there's different ways I could have done this. But it was good that he chose the -2, but you're right, I could have gone down to -8 and just done the slope of up 3 over 1, up 3 over 1, back 3 over 1, back 3 over 1. But I do need to go all the way to -2 and no further. Why? Why do I have to go back to it? I need the graph to start where it tells me. And even though it's an open thing, I need to plug in the -2 to say, well, it's not right there, but at -2.000000001, it's gonna start up. So I'm gonna be like, itty bitty teeny tiny smidgen to the left of that, so that open circle will go forward. Yes?
Why would the open dot be at -8, -2?
Okay, is the coordinate, you said -8, -2. That coordinate is when x is -8, which is over here, and y is -2.
Or -2 is -8.
Okay, -2, -8. When I plug in -2 for x, which is what Fernando did, 3 times -2 minus 8, -6 minus 8 is -14. Okay, so the coordinate that's on the graph, that -8, coordinate that's on the graph is 0, -8, not -2. Good. It's Friday. And a pep rally. Roar. Pep. All right. Can we go back to, so again, entrance card on limits and stuff, that looks a lot like the Delta math, that is the homework, that's due Wednesday. Entrance card is Wednesday. Tuesday, we're gonna go over more things on graphing and stuff to make sure that you're especially prepared. And a warning, highly likely you will have a quiz on Thursday or Friday next week, like a legit quiz, not just an entrance card or an X card. So something that's worth double digits of points. Okay, Jean, can you put the laptop away? And can we do top of page 5, page back to it?
Well, I know it's one.
fill out a thing,
Oh, mine is
but later.
I haven't been, I'll tell you what,
No,
I've been paying attention more this year than the last.
But, well, it is not blank, so picture, you have the whole picture, it's not graph. Is that what it works?
Wait, are you on? Yeah, I'm on. But yeah,
All right, guys. Yes,
I was.
okay. How many pieces, Khalil, to this piecewise graph do I have? Defined in the function. We don't have anything drawn yet, so we need to figure that out. How many pieces? Two. There's two pieces. So I'm gonna make an XY grid for each of them. And I'm gonna do them in two different colors so that we can really see what's going on. Okay. And even though these symbols don't say equals sign, I am going to start both of them at that number. Because really, 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 really close to zero, it's hard to plug in 0.00000001. I'm gonna just say, let's pretend that it actually is zero. So, Emmanuel, tell me numbers that fit this condition. More numbers from zero that x is greater than zero that I should put down here. Is -1 greater than zero?
Oh. Oh, one.
Okay, 0, 1, and 2. All right, so Emma, plugging in 0 for 3x minus 2.
You get -2.
You get -2. Louisa, plugging in 1 for x, what do I get? 3 times, just positive 1. Conchetta, plugging in the 2. 3 times 2 minus 2. 4. All right, so let's plot those dots. Oh, I need axes. And just in case you're like Abraham and never heard me say that you need a scale with numbers written on it, you need a scale. You need to put the numbers down. Even if you're like, oh, well, it's assumed that each block is 1. I need you to write it down. So Isaac, I'm gonna plot the coordinate 0, -2. How do I do that?
You start at 0 and go 2 down.
So start at the x value of 0 and go 2 down. Do I color in the circle or no?
No.
No, because
No, it's not.
no equals. And then the coordinate 1, 1, and then the coordinate 2, 4. I didn't draw 1, 1. 0, -2, 1, 1, 2, 4. Okay, you guys okay with getting that piece? Yeah.
So if we only wanted to do 3x values, we could. And like, could we do like just 3 the middle one you want?
Yeah.
Okay.
So, these are straight lines, so 3 points is good.
Okay.
But when we get to curvy things, you're gonna need more than 3
Okay.
points. Clara, you ready or no? You still working? Okay. For this branch, what x values am I gonna check? Like pick some numbers that fit. X is less than 0.
Like -1 and -2.
Yeah, 0, -1, -2. Jose, plugging in the 0, what do I get for x? Or what do I get for y? 4. Danny, plugging in -1, what do I get?
0.
0. Martha, plugging in -2, what do I get? -4. I plot the coordinate 0, 4?
You go up 4.
So go up 4, solid or open dot?
Open.
Open because,
It's less than
because it's strictly less than 0, no equals. All right, then -1, 0, and -2, -4. So there's our graph, our piecewise graph. So Alex, you said, I don't know how to do this, it's old. And I don't know how they did it in Louisiana, but does it make sense to make 2 table pieces? And do you guys see why we chose these numbers for this one, but totally different ones for the other piece? I needed, for the blue one, I needed numbers, x values bigger than 0. For the green one, I needed x values less than 0. And I put the 0 in on each of them because I want to know right what happens when it breaks. All right, so now going back to what we did days ago. Eleanor, the limit as x approaches 0 from the left. Is that the green side or the blue side? The green side. So coming at it from the green side, what's the y value if x could actually get to the 0? 4. Cherry, the limit as x approaches 0 from the right. Is that the green branch or the blue branch? Blue. So coming at 0 from the blue side, what's the y value going to be? You could look in your table as well. Coming at it from the blue side, when we get to 0, what's the y value?
4.
Blue side,
-2.
-2. Alex, what is the function when we actually hit 0? In this description of the function, where do I tell you when x equals 0, do this?
Does not exist, because there is no equal sign.
Does not exist because I didn't put an equals in there. Perfect. All right, Khalil, can I draw the green and blue line without picking up my finger? No, so there's a discontinuity. What kind of discontinuity? Here's your 3 choices. It's removable, meaning you could build a bridge and drive over it. It's a jump, meaning there was an earthquake and broke the bridge apart, the road apart. Or infinite, where you're taking a nice leisurely drive along the river off to infinity. It's not removable, you're right, it's not removable, I can't. Is it infinite, Nadette? It's jump, why is it jump? Here is your reason why it's a jump. Because 4 doesn't equal -2. So you needed the limits that we already have written on the paper, so I'm not gonna write them again. But the reason that it's a jump discontinuity, because the limit from the left went to 4. The limit from the right went to a -2. 4 and -2, not the same number. That's a jump. That's your bridge, earthquake happened, pulled the bridge apart. You're not gonna be able to drive your car across that. Okay, can you guys do this one on your own? Fill in the boxes, put in your grids, and Abraham, what do you need to make sure you put on your axes? What do you need to make sure you put on the axes? Numbers, a scale, yes.
I have a question.
Yes.
For D, what,
Which page?
So if the discontinuity is removable, is this removable? So this doesn't apply.
So no.
So it's not removable on that last discontinuity, so there is no way you could have fixed the problem. There isn't a bridge your car could drive across that we could build. It would need stairs.
one, and they want dates and times on it, they
Yeah.
want the details. Which you could fill out yourself.
Yeah, I know it. Oh, on the tax, I thought you meant on the. Sorry, Isaac, what was the question?
This is like on the.
Oh, let me hand the rest of them out first. Yes. So, these numbers, you got 3. Okay, and these numbers you got. Perfect, okay, so let's plot the dots. I need some axes, and Abraham, what do I need to put on the axes? Numbers, perfect. And I like your idea of 1 unit per block, all right? So I'm gonna go the coordinate 1, 3, and looking at this, does it have does it have a solid line or not? On the symbol for the inequality, is there equals? No, so I'm gonna leave the circle open. And then I'm gonna plot the coordinate 0, 1. When x is 0, it's 1. At -1, it goes to -1. -2 goes to -3. I'm kind of getting the idea. Okay? And then we're gonna take the numbers that you found for the other side, 1, 6, 1, 6. Looking at this bit, does it have the solid line on the symbol? So I'm gonna color the dot in. And then I'm gonna plot your other coordinates. 2, 5, 3, 4. Is it continuous? Kira, is it continuous?
No.
No, because I had to pick up my finger when I went from purple to red. Is it removable, jump, or?
John's constant.
Okay. Jump. And it says justify your answer using limits. Okay, gross. The limit as x approaches, where's the problem child? Where do things break? At 1. So 1 from the left. Is the left the purple or is it the red? Purple. So where does the y value go when we're coming at it from the purple side? 3. And then I need to say the limit as x approaches 1 from the other side, where does it go? 6. And because 3 does not equal 6, in any math system I've ever had to work in, it's a jump discontinuity, because it went to this number, this other number, they're not the same number, so it's a jump. And just because we need to remind you of all kinds of things, Abraham, what's the domain? What are the x values I'm allowed to choose? To,
No, 1.
okay, can I, is it defined at 1? Can I plug 1 in and get a value?
No.
Sanchetta says yes.
Oh, wait, perhaps it's no,
Uh,
it's a search.
That's
Oh,
not filled
right,
in, but
right, right,
immediately
right.
above it it is, so. The domain, even though there's a break, pick any x value, I'll tell you there's a y.
Okay, so you include both lines when you're counting domain.
Yes, you include the whole function, which is both pieces. Emmanuel, this is kind of tricky. What's the range? What are the y values? Where's the lowest y value out there? and mind these arrows go. Infinity, positive or negative, negative infinity. And then coming up, I'm hearing 6, I'm hearing whispers of 6. Would it be a square bracket? Okay, and this is correct, but a lot of you fall for it. Looking at this one with the 3 and it's open, a lot of you wanna be like, oh, but I can't include that one. But you can, it's colored in over here. So there is a y value, there is a place where y is 3. And 3.1 and 3.2 and 4 and 4.1 and 4.89. Okay, domain and range, domain is all the x values in, range is all the y values out. Vaguely familiar? Laura? How y'all doing? Big plans for the weekend? Anyone going away? Yes, no? I had one student that emailed me, but I never got the email, but he's like, yeah, I'm flying to North Dakota. Suddenly my mom decided to take me on vacation, so can I take the quiz early? He was complaining that, oh, I have to go on vacation. I get the great tests, thank you. Oh my goodness, just cause it's there and the bell hasn't rung yet. Oh no, I'm done too. The look of joy on your face, you were like, oh, please don't. Y-intercepts, Nava. When I hit the y-axis, what's the x value?
The y-axis, the x value here is 1.
Okay,
Or wait, sorry, 0.
okay. When you hit the y-axis, the x value is 0, and the y value here, in this case, is 1. Okay? Yeah.
Will we ever do a table where the limit or equals does not exist?
Ooh, limits might not exist, correct. Right now, ooh, lovely question. Okay, what is the limit as x approaches 1? Not from the left, not from the right, just 1. Embry, what is the limit of the function that's drawn there?
Does not exist.
Does not exist. Why? Alistair? They don't go to the same y value, so if you need 2 fingers to walk up to it and they go to 2 different places, does not exist. Okay. Good enough? All right, so over the weekend, please join Delta Math, and I highly recommend you do it. It's not due till Wednesday morning.